Welcome to the fifth video lecture for ENSC 2613. Today we will cover power association and dependent sources. When we talk about power association, we are determining whether or not an element in the circuit is delivering power or absorbing it. The power is always calculated by the voltage across the element multiplied by the current through the element, but if the current flows out of the positive side of the voltage, then the element is delivering power. If the current flows into the positive side, it is absorbing power. This will make a little more sense after we work a couple examples. In this problem, we are asked to find the power associated with the 1 ohm resistor. Using techniques from previous videos, we can see that the current through the resistor is 5 amps, and the voltage across it is 5 volts. Power is voltage times current, which is 5 times 5, which is 25 watts, and since the current flows into the positive part of the voltage, then we have 25 watts absorbed. In this problem, we're asked to find the power associated with the current source. Using techniques from the past, we can see that there is 12 volts across the current source. We know that the current source has a 1 amp value, so the current through it must be 1 amp. P is equal to VI, which is 12 times 1, which is 12 watts. And since the current flows out of the positive, then it is delivering power. So we have 12 watts delivered. Now we're going to talk about dependent sources. In all of our previous examples, we had sources that were independent. Their values were always the same, regardless of what was going on in the circuit. With a dependent source, the value of the voltage supplied or current supplied is dependent on another value calculated elsewhere in the circuit. In this example, we're asked to find Ix. Ix is going to be the voltage of the dependent source divided by the 10 ohm resistor based on Ohm's law, but first we have to find Vx. We know that Vx is equal to 5 based on the voltage divider rule, and that means that Ix is 4 times 5, which is 20, divided by 10, which is equal to 2 amps. In this example, we have a current source, and we are looking to find V0, which is the voltage across the 10 ohm resistor. The current source has a value of Vx, which is again 5, and V0 is 5 times 10, the current times resistance, which is equal to 50 volts. Now, these last two problems were relatively simple because the dependent source was isolated from where it was defined in the circuit. But in this example, we have to be a little more creative. We need to find Ix, and in order to do this, we have to set up some equations based on rules that we know to be true. We know that Vx is equal to 10 times Ix, because that is Ohm's law, and Ix is equal to 60 minus 4Vx divided by the resistance in between the nodes. This was also based on Ohm's law. This gives you two equations and two unknowns, which are Vx and Ix, and you can use a little algebra to solve these and see that Vx is equal to 10 volts and Ix is equal to 1 amp. Here's a bonus problem for you guys to work. You should see if you can find the power associated with the dependent source. If you're having difficulty working these problems, please feel free to contact your instructor or teaching assistants and we'll be happy to help you. We'll provide the answer so you can see if you are doing it correctly. Come back next time and we will cover nodal analysis.